Hello everyone, welcome to our YouTube channel, World of Software Testing. So far we have started the black box testing techniques in our previous lecture, and we have already covered the boundary value analysis. So in this lecture, let's discuss about the second test design technique, that is the equivalence class partitioning, or also called as the ECP technique. So we have also discussed about this black box testing techniques, why we need this. The main goal of test design technique is to reduce the data and increase the test coverage. So the data which we have prepared as a test data, with that data we should be able to cover all the scenarios of the testing. And also the test case design techniques helps to design better cases and reduce the number of test cases to be executed. So these are the main goal of the black box testing techniques, and it can be also termed as a test design techniques and the test data design technique or the test case design technique. So basically these are useful to design the better test cases in parallel increasing the coverage. So these are the black box testing types. We have already covered boundary value analysis, BVA, out of this, and the rest we will start as a equivalence class partitioning in this tutorial. So let us understand about the equivalence class partitioning technique, or the ECP. So the equivalence class partitioning is a black box testing type or a testing technique or a specification based testing technique in which we group the input data into logical partitions called as a equivalence classes. In this technique, input data units are divided into the equivalent partitions that can be used to derive the test cases, which reduces time required for the testing because of the small number of test cases. So again, as we already discussed in our previous lecture, practically it's not possible to do the exhaustive testing with each test data date. So it's better to have some technique to reduce this data, also in parallel improve the coverage. So it divides the input data of a software into different equivalent data classes. So you can apply the ECP technique where there is a range in the input field. This is more like a testing the actual data types such as numbers, alphabets or uppercase, lowercase, special characters, blank space. So yeah, so we are checking the data type in with the help of the equivalence class partitioning. So let's understand this with the help of example of a college admissions. So here we have the text box, we can say the marks, which accepts the marks between 120 and 180. So consider that the colleges will provide the admissions to students based on the CET marks here. So out of 200 total marks, colleges accept the students with the marks between 120 and 180 for the admissions. So for students having the marks less than 120, here we can say less than 120 and greater than 180, they don't accept for the admissions because the criteria is between 120 to 180. So we have below we have this text box here. So if the student try to enter marks less than 120 and greater than 180, it throws an error, means it is an invalid input because it's not accepting that those marks here, right? So if you are try to enter, let's say 110 here, or maybe we can say 190 or 193, this is not accepting, this should not accept this kind of marks in this text box. So in this way we can create certain classes to test such text boxes, which will help reduce the time required for the testing, as we are only going to test for these three classes, because we cannot do the exhaustive testing right from 120 to 180, or maybe we can say, let's say for example 1 to 180, we cannot test like that. So we need to create these classes here. Any one value is less than 120, any value is greater than 120, and then any value lies between 120 and 180. Those will be valid only. So let's see some of the more examples here. We have this text box again. Enter the number here, which allows digits from 1 to 400. So again here we cannot go and cannot check if it accepting from 1 to 400, right? Because we cannot check it 400 times here. So instead of testing this data 1 to 400 individually, we can use the ECP technique and reduce the data and can cover everything, all the scenarios with a small set of data. So to create this, divide the entire data into multiple classes, that is the partitioning. So here in this example, if you see the first table, which is normal test data. So with the normal test data, we need to enter each and every value once in this text box and need to test if it's accepting or not, or if it is working as expected or not. So this is very time consuming. So we cannot do this with the normal test data. So we need to divide this data into the classes here. So we can see we have a range from 1 to 400, right? So here what we have done is, so we have created these classes. First we have done from -100 to 0. Okay, so this is one class here. From 1 to 100, this is the second class. From 100 to 200, then 201 to 300, then again 301 to 400, and then 401 to 500. So whatever the values or the classes are outside of this ranges can be classified as a invalid, and whatever comes within this can be classified as a valid values. So here this is invalid, right? Because this is -100 to 0 and we start from 1 to 400. So this can be considered as a invalid. Then just take one value from this which should not get accepted in this text box. Then again in the next class 1 to 400, just take one value here, 90 we have taken, which should be valid and which should get accepted in this text box. Similarly, try this for rest of the classes here. And then one more thing, so if we are trying to use this 400 to 500, so if you try to enter 450, it should not be accepted in this text box. So these two values will be invalid and this will be the valid. So we can perform the positive testing with the help of this valid scenarios, valid values, valid inputs, or the valid test data, and we can perform the negative testing with the help of this invalid test data, which should not get accepted within this text box. So with the help of the equivalence class partitioning, we have this data here now. So we have to test only this 1 2 3 4 5 6 values. We should be entering this first -70, which should not get accepted. Then 90, which should get accepted. 150, 260 and 340 should get accepted. And then for 140, this should not get accepted as those are the invalid values, and this all should get accepted. So from normal test data to equivalence class partition data, we are reducing the data here, but we are improving the coverage because we are covering each and every scenario with this only 6 values of input in this test data. So instead of testing it on the 400 time here, we just need to test it 6 times. So this is the main goal of equivalence class partitioning, to reduce the data with partitioning the classes here, and in parallel just improve the coverage. So let us understand again with this test data type here now. So here we have a text box which allows alphabets only. Okay, so now there are few things we need to keep in mind. So equivalence class partitioning, when we deal with the numbers here, then we are dealing with the number data types. So here are some of the data types. So first is numbers, alphabets, special characters, then the spaces, So these are the data types, and we need to deal with these data types with the help of equivalence class partitioning. So now this text box is allowing only alphabets. So here we need to again divide these values into the classes here. So we have these classes. So if you consider the alphabets, then there are the capital A to capital Z. This is then second one is A to Z, small a to Z, small letters. Then the special characters, there can be a lot of special characters we can use, and then numbers 0 1 2 3 4, so and so on. Then the spaces, we can use the spaces as well, but here our requirement is the allow only alphabets. So here we can only use this A to Z and small a to Z here, because those will be valid only, and then these all will be invalid. So here with the help of the ECP technique, we can find out this data to check this text box. So with this first two, it should get accepted within this text box, as they are the valid inputs called as the positive testing or the positive scenarios, and then this remaining one are the invalid inputs. These should not get accepted in this text boxes, which is termed as a negative testing. So in this way we can just reduce the data with the help of equivalence class partitioning. Let's understand this with the help of example here. The customer requirement is that for a login page, username text box field should contain 6 to 9 uppercase and @ character here. So @ is a special symbol now, special character, and uppercase alphabet it should accept, and numbers only, so numbers as well. So these are the three data types it should accept. So here as we already discussed about the boundary value analysis, so the range is 6 to 9. So for BVA, we are finding out the minimum is 6, maximum is 9. So we are finding out the minimum -1, minimum +1, max +1, and max -1. So again, max here, if you see, the max is valid, max +1 will be invalid because this is out of range, and then max -1 is valid, min is 6, then min +1 is equal to 7, that is valid, and min -1 which will be invalid. So these two will be invalid out of this. So we can reduce the data with this the BVA, which is related to the input length. Okay, this is the range. And then the equivalence class partitioning, which is related to the input data type. So we have discussed, we have a lot of data types here, the alphabet, special characters, numbers, spaces. So this is related to the input data type. So now we can accept 6 to 9 uppercase characters. So uppercase, if you see, so we can have uppercase letters. So A to Z is maximum the capital A to Z we can accept here. These are the valid inputs. So special characters @ we can accept here, and numbers. So numbers are 0 to 9. So we can accept these numbers. And whatever the invalid inputs, so lowercase will be A to Z, special characters, and then the blank space. So again, with the help of this, we can reduce the range here, and we can test the username text box field. So there is one more example we have for a login page. The password text box should contain maximum 10 lowercase alphabets and the numbers letters. So here, if you see, the maximum 10 lowercase we can accept. So again, minimum will be 1. So min -1, and the max +1, which will be 11, and 0 will be invalid, out of range. So again, equivalent partitioning, we have valid and invalid inputs. So we can accept maximum lowercase alphabet. So here there should be the alphabet, the lowercase alphabets, and then numbers 0 to 9. And then here the uppercase will be A to Z, which will be invalid. So all special characters will be invalid, and blank spaces will be invalid. So this is, in this way we can use the ECP. So these are some of the advantages of ECP. It is process oriented. We can achieve the minimum test coverage because we are reducing the data. I think this is wrong. I mentioned this is maximum coverage with a minimum data. It helps to decrease the general test execution time and also reduce the test set of data. Okay, so there has to be minimum test coverage or maximum test coverage. Sorry, I'm again writing the same thing. So maximum test coverage here. Maximum test coverage and the less test data. These are the advantages of ECP. So thanks for watching this video. Hope you have liked this video. Please do subscribe our YouTube channel for such more videos and click on the bell icon to get the latest updates. In the upcoming lectures, we'll dig further into the black box testing techniques. Thanks for watching.